Space is big, you've heard that before. But big doesn't really capture it. Big is a word we use for oceans and mountains. What we're talking about is something your brain is fundamentally not built to hold. And inside that incomprehensible scale, there are things that should not exist. Things that break physics. Things that swallow light. Things so cold they stop time itself. Things that could end everything and wouldn't even notice. Today we count them down. A quick note before we begin. This isn't a list of monsters or sci-fi villains. Everything on this list is real. Confirmed by observation, verified by physics, documented by astronomers who, frankly, probably wish they hadn't looked. We're going from unsettling to truly, cosmically terrifying. Let's start. Number 7. Magnetars. A magnetar is what you get when a star larger than our Sun collapses into a ball roughly the size of a city, about 20 kilometers across, but retains the mass of the original star. The result is the most magnetized object we know of in the universe. How magnetic? If a magnetar were positioned halfway between Earth and the Moon, about 200,000 kilometers away, it would pull the iron out of your blood. From 200,000 kilometers. Its magnetic field is roughly a quadrillion times stronger than Earth's. That number has 15 zeros in it. It would erase every credit card on Earth from the distance of the Moon. And they pulse. Some rotate dozens of times per second, firing off bursts of X-rays and gamma radiation. In 2004, a magnetar 50,000 light-years away released a burst that briefly affected Earth's upper atmosphere, despite being almost incomprehensibly far away. The universe has stars that can reach out and touch us from across the galaxy. That's number 7. Number 6. Rogue planets. Most planets orbit a star. They're anchored, predictable, gravitationally committed. Rogue planets have no star. They were ejected, thrown out of their solar systems by gravitational chaos during the early formation of their systems, or simply born alone in the void between stars. They drift through interstellar space in total darkness, with no heat source, no light. Astronomers estimate our galaxy alone may contain trillions of them. Trillions of frozen, lightless worlds, silently moving through the dark, completely invisible until they're close. Now here's the part that earns this a spot on the list. If a rogue planet passed close enough to our solar system, its gravity could destabilize the orbits of our planets. No explosion, no warning, just a slow, inevitable unraveling. An object we'd barely see coming, reshaping our home from a distance. A ghost of a world, drifting through the dark. By the billions, you'll never see most of them. Number 5. Gamma ray bursts. The most energetic explosions in the observable universe. In a matter of seconds, sometimes less, a gamma ray burst releases more energy than our Sun will emit across its entire 10 billion year lifespan. They come in 2 types. Short ones, lasting under 2 seconds, are caused by neutron star collisions. Long ones, lasting up to several minutes, mark the death of a massive star, a hypernova, collapsing into a black hole and firing twin jets of radiation across the cosmos at nearly the speed of light. Now, the part that matters to us. If a long gamma ray burst fired in our direction from within a few thousand light years, its radiation would strip away our ozone layer within seconds. What followed would be mass extinction from ultraviolet radiation. There's a reason some scientists think gamma ray bursts may be responsible for some of Earth's great extinction events. We survived those, barely. The disturbing part? Gamma ray bursts are happening constantly. Somewhere in the universe right now, one is going off. We just haven't been in the way. Yet. Number 4. Boltzmann Brains. This one is less a physical danger and more a philosophical terror. Given infinite time and a universe that persists long enough, quantum fluctuations, the random, spontaneous appearance and disappearance of particles, make almost anything statistically possible, including the formation of a fully conscious mind, complete with false memories, arising spontaneously from nothing. Physicist Ludwig Boltzmann proposed this thought experiment over a century ago. If the universe lasts long enough, and some models suggest it will, for an incomprehensibly long time after all the stars go dark, then random fluctuations of matter will eventually produce conscious observers far more often than biological evolution ever did. Here's the horror. Those observers would believe they had lived real lives. They would have memories of this moment, of childhood, of people they love, all of it an instantaneous quantum accident. Some cosmologists argue this is a serious problem. If Boltzmann brains are more probable than naturally evolved minds, then statistically, the odds that you are one are uncomfortably difficult to rule out. Moving on. Number 3. Black holes. You knew they'd be here. But do you know how strange they actually are? A stellar black hole forms when a massive star collapses. Gravity compresses so much mass into so small a space that it creates a singularity, a point where the known laws of physics break down entirely. Our equations don't just fail, they divide by zero. They produce infinities. The universe stops making sense at that point. Around the singularity is the event horizon, the boundary beyond which nothing, not even light, can escape. It's not a surface, it's not a wall. It's just a region of space where the future only points inward. Supermassive black holes are more unsettling still. The one at the center of our galaxy, Sagittarius A*, is 4 million times the mass of our Sun. The one at the center of galaxy M87 is 6.5 billion solar masses. It is larger in diameter than our entire solar system. But the real horror of black holes is the spaghettification. If you fell toward a stellar black hole, tidal forces would stretch your body into a thin stream of particles, lengthening you into an atom-wide ribbon, while from the outside, an observer would watch you slow down and freeze at the horizon, red shifting into darkness, never quite arriving. You would experience oblivion. They would watch you become a ghost. Number 2. The Fermi Paradox, the Great Silence. Our galaxy is 13 billion years old. It contains somewhere between 200 and 400 billion stars. Statistically, a significant fraction of those stars have planets. A significant fraction of those are inhabitable zones. And life, at least on Earth, arose remarkably quickly once conditions allowed it. So where is everybody? This is the Fermi Paradox, and it doesn't have a comfortable answer. Option 1. We are genuinely alone. In a universe of hundreds of billions of galaxies, each with hundreds of billions of stars, we are the only minds that arose. The silence is real. That's terrifying in one way. Option 2. Life arises, but something stops it. Every civilization hits a wall, a technological threshold, a self-created catastrophe, something in the nature of intelligence itself that extinguishes it before it can spread. The great filter. And if that filter is ahead of us rather than behind us, if we haven't hit it yet, then the silence is a warning. Option 3. They're out there, but they're not talking, or they're waiting, or we are simply too primitive to detect what they're sending. The universe is 13.8 billion years old and is vast beyond comprehension. The silence is deafening, and we don't know why. If you would like more content like this, please like, comment, and turn on notifications. Number 1. The heat death of the universe. Everything ends. You knew that. But the scale of the ending is something different. In approximately 10 circumflex 100 years, a number so large that writing it out in standard notation would require more digits than there are atoms in the observable universe, the last black holes will have evaporated through Hawking radiation. Every star will have long since gone dark. Every planet will have decayed. Every organized structure will have dispersed into a thin, cold, featureless soup of particles at maximum entropy. No heat gradients means no energy transfer. No energy transfer means no work. No work means no processes. No processes means nothing happens. Not slowly, not occasionally. Nothing happens at all. Forever. There is no explosion, no great collapse, no dramatic ending. Just a universe so old, so spread out, so thoroughly spent, that it becomes indistinguishable from nothing, while technically still existing. This is, as far as physics currently tells us, the most likely fate of everything. Every person who ever lived, every civilization that ever rose, every star that ever burned, a faint, temporary disturbance in something that was always trending towards silence. The universe isn't hostile, it's indifferent, and somehow that's worse. And yet, here you are, in the brief, improbable window when stars still burn, when planets still hold oceans, when minds still exist to look up and ask questions. The universe is terrifying. It's also extraordinary. If you're watching this, you're a temporary arrangement of atoms that figured out how to be curious. In this ever-expanding universe, and that's not nothing.